Okay, so in this problem we're going to try and find what is the minimum number with an exact number of factors. In this particular case, we're going to be looking for the minimum number with exactly 6 factors, but this is a general property you can apply to any minimum number with an exact number of factors, and it comes down to depending on the fundamental theorem of arithmetic. And if you're a bit rusty on that, it's just the statement that any number can be expressed as the product of primes. So usually this is written a little bit like this. So any number n is the product of prime numbers. So the first prime times the second prime times the third prime, all to some power. Now, so we just say that the power of the first prime is alpha, power of the second prime is beta, power of the third prime is gamma, and so on and so on and so on. So to give you an example that's reasonably simple, let's say our number is 4, we can rewrite this as the product of 2 squared. Simple enough. If we've got something more complicated, like say 14, we can still write it as the product of primes. It's 2 to the power of 1, 3 to the power of 0, 5 to the power of 0, and then 7 to the power of 1. Right? Because 2 times 7 is 14, and so on and so forth, for any number at all. Now, when that holds, there is a way you can calculate the number of factors that that number n has. So to calculate the number of factors of that number n, that's just the product of the powers plus 1. So alpha plus 1 times beta plus 1 times gamma plus 1 plus, and so on and so on and so on and so on, into infinity, as far as you like to go. So using this is all of the kind of mathematical framework we need to solve this problem. So in our particular problem, we're looking for the minimum number with exactly 6 factors. So we want to find out, using this relationship here, right, how many different ways can we get the number 6? And that's just a fancy way of saying, what are the factors of 6? So if we've got the number 6, we can write it as 2 times 3, or we can also write it as 1 times 6. Exactly the same thing. And we don't know which one of those is going to give us a bigger number. But if you have a look at, if you compare this expression here, so 2 times 3 with the relationship above, you can actually see that 2 times 3 could come out of the product of those two terms here. So if you write that 2 times 3 is equal to alpha plus 1 and beta plus 1, right? Because there's only 2 numbers in there, so we don't need to worry about the gamma term and so on and so forth. We can see that for this 2 times 3 factor set, our alpha must be equal to 1, because 1 plus 1 is 2, and our beta must be equal to 2, because 2 plus 1 is 3. And we can actually do the same thing for this 1 times 6. So we go 1 times 6 equals alpha plus 1, beta plus 1, then our alpha is going to be 0, and our beta is going to be 5. Right. So we figured out our alpha and betas for our number 6 for 2 different situations, but now we need to figure out which one of those is going to give us the smaller number, because remember we're looking for the minimum. And if we go back to the relation we started with at the top of the page, this one here, there's actually a really easy way of figuring out what that number is, just substituting into this formula. So if we want to calculate the number n, all we need to do is give prime 1 to the power of alpha, prime 2 to the power of beta, and so on. So let's do it for this case here, so the 2 times 3 case. So our number n is p1, p2, alpha, and beta. And our first prime, because we want the minimum number, we're going to stick the maximum of alpha and beta onto the smallest prime. So 2 to the power of 2 times 3 to the power of 1. So we're just saying that our beta goes on 2 and our alpha goes on 1. Now, hopefully you can do that in your head. It comes out as 12. Now for the second case above, so for the 1 times 6 factor that you can see here, we need to check it again, see if we get a bigger or smaller number. You can probably tell which one we're going to get already, but we'll work through the motions. P2 beta, and now we're going to have 2 to the power of 5, because our beta is our bigger term. 2 to the power of 5, 3 to the power of 0, and that is 30. Sorry. 32. And so those are our two possible numbers. 12 is significantly smaller than 32, so therefore the smallest number with exactly 6 factors is 12. Done.